So today we are going to solve this problem 518 coins change to. So in this problem you are given an integer amount, means this is the total money you want to make, okay, and an array of coins. Each coin has a value and you can use each coin multiple times, okay. So the problem is find how many different ways you can make the amount using the coins, okay. So that's the problem. See, so the something, so the order of coins does not matter. For example, like 1 2 and 2 1 are the same, okay. So let's understand. They take a coin. We have coins like 2, only one coin, and the amount is 3. So ways to make 3, we only have point 2. We cannot make 3 using only 2, okay. So the answer is 0. So there are 0 ways. Next is, let's take another example. If we have now 1 2 and the amount is 4, so way to make 4, first we can use 1 place 1 2 1 2 3 4, 1 1 1 1 one way. Next is 2 place 2, one way, 2 way. Next is 1 place 1 place 2, 3. So there are total 3 ways, okay. We can make 4. So see, start with the first coin, okay. So the idea is start with the first coin. For each coin you can use it and reduce the amount. If we reduce the amount, 4 minus 1 is 3, okay. And if we skip it and go to the next coin, so we go to the next coin. If we skip, we have two choice, one take and one skip. If we use, we can reduce the amount. If we skip, it goes to the next coin, okay. So repeat until amount becomes 0. If amount becomes 0 means one way, okay. Count is 1. So let's try then. Okay. Let's take a small example. 1 2 and amount is 2, okay. We want to know how many ways we can make using these coins, okay. Using these coins, make 2 using these coins, okay. So let's start. We start with solve of 0 comma 2. 0 means index value 1, 2 means amount, okay. 0 coin, index 0, coin is 1, 2 amount we want to make, okay. So here we have two choice. Take coin 1, amount decrease by 1, so new amount is 1, okay. If we decrease 1 minus 2 minus 1, and so the new amount is 1. Stay on the same coin. Stay on the same coin index. So solve of 0. So here we write here, okay. Solve of 0 comma 2. Here we have two choice, 0 1, okay. If we skip 1 2, see, skip coin 1, move to the next coin, index 1, coin is 2, so the amount stays same, okay. Now next, see, coin 1 amount is 1, coin 1 amount is 1. So here, so we have two choice. Take 1, amount 1 minus 1 is 0, okay. Base case is, so it's hit the base case. So here we are going to return one way. If we skip, move to the next coin, index 1 coin, so solve of 1 comma 1, okay. See, solve of 0 amount is 0, we return 1. Solve of 1, coin is 2, so the amount is 1. We take 2, amount 1 minus 2 is here, see, okay. We take 2, okay. 1 minus 2 is negative 1, so it was invalid, so here we are going to return 0. So we skip, no more coins left, so here 0. So see, solve of 0 comma 1, 1 0 is 1. Okay, and they are one way. Next, see coin of 2. Okay, so here also we have two choice. Coin is 2, amount is 2, so they have two choice. Take 2, amount 2 minus 2, 2 minus 2 is 0. Here we are going to return 1. Here we are going to return 1. And if we skip, no more coins left, so from here we are going to return 0. So the maximum is 1. 1 plus 1, so the answer is 2. Okay, so there are total two ways, so the answer is 2. See, every node has two options, take or skip. Left side, take, amount decrease, stay same coins. Right to skip, move to next coin, amount same. Okay, base case all when amount is 0, one way, all no coins left, so here we are going to return 0 base. Okay, so let's write down the code. See, first we want a function solve of I int solve int I and a mou and amount, and we ec t-var vector int and coins coins. Okay, so I is current coin index, which coin we are using now. Okay, and the amount is remaining amount we want to make. Coin list of all coins, so why we need to track which coin we are not at and how much amount is left. Okay, now we write a base case. If amount is equal to 0, return 1. See, here we are returning 1 because amount is 0, here we are going to return 1 way. If remaining amount is 0, okay, we successfully made the target using some coins, so we return 1 means find one valid way. Okay, so next base case, see, if 1 0 0 1 2, if go out of bounds, in this case, to handle for this case also we want, if I is equal to coins dot size, return 0. Okay, next is we have two choice. One is a take int take is equal to 0 if amount is greater than or equal to coins of I. Take is equal to solve of I amount minus coins of I coins. Okay, next is skip. Wait, let me explain this line. So take way, if we take the current coin, why we take amount is greater than or equal to coin of I means we cannot take coin bigger than remaining amount. Okay, so we call the function solve of I and amount minus coin of I and coins. So stay on same coin index because there are infinite coins. Okay, there are so many coins. So is see, take solve of 0 comma 2. So coin 1, amount is 2, so coin is 1, amount is 2, can take new call is solve of 0 comma 1. Okay, so 0 comma 1, coin 1, amount is 1, so we take, so the new call becomes solve of 0 comma 0, so it was base case, it was 1. Okay, next is skip. We have to skip also, no? Wait, let me write first. In skip is equal to solve of I plus 1, amount, coins. So in last, just we have to return take place skip. Let me first complete this code, then I will tell you. Return solve of 0, amount and coins. Something is wrong. AMOUNT. Okay, see why total waste, see total waste is equal to waste if take coin place waste if we skip coin, so return this value of parent call. So see, in last we have written, first we see this in skip case what we have done, waste if we skip current coin, so why we have used I plus 1, we move to the next coin, amount stays same. Okay, see solve of 0 comma 2, solve of 0 comma 2, here it's solve of 0 comma 2, we skip, we move to I is equal to 1, coin is 2, so it new case becomes solve of 1 comma 2. Okay, 1 comma 2. Next 1 comma 2, if we skip, it's come here 1 comma 2. Okay, so 1 comma 2 also have 2, coin is 2, and the amount is 2, so it takes solve of 1 comma 0 it one way, so we skip solve of 2 comma 2, so no coins left, so it was 0. Okay, so in last we just return I plus 1. Okay, so see, we cannot use recursion because let me explain first this. Okay, see, first the function is solve of I, amount and coin. Okay, explore all ways to make amount starting from coin I. Okay, next is base case. If amount is equal to 0 successfully, so here we are going to return 1. If I is equal to coin dot size, no coins left. Okay, if it's go out of 1 to like out of 1, so in this case we are going to return 0. Okay, so we take 2 calls, take and skip. Okay, so see, let's take a small example, 1 2 and the amount is 2, so solve of 0 2, here we have 2 options, take 2 0 1 2 minus 1 1, if we skip 1 comma 2, 2 option 0 1 minus 1 0 1 1, 2 option 1 0 to 2. Okay, let me explain you. See, solve of 0 0, solve of 0 comma 0 one way. Okay, so solve of 1 comma 1, it was 0 ways, there are no ways. Okay, so solve of 1 comma 0 comma 0, it was one way. So solve of 2 comma 2 comma 2, it was 0 ways. So solve of 2 comma 2, so the total 1 1, so the total is 1 plus 1 2, so the answer is 2. Okay, see, we cannot use recursion because recursion make too many repeated calculation. Okay, recursion make too many repeated calculation, that's why we cannot use recursion. So first, but we can use memoization. Memoization means, memo means store result of recursion, save time, make recursion fast. Okay, that's it. Memoization is, let's convert this code in memoization. Unordered, we create a map. Yes, tri and the string and int memo. Next, we create a key, string key is equal to string of I plus space plus 2 stri and the string of amount. Okay, if memo dot count key is exit return stored answer memo of key, and last return memo of key is equal to okay, sometimes we cannot use memorization also in this. Now we going to use tabulation, dp. Okay, see, the problem is count number of ways to make amount using coins. The recursion idea is, see, solve of I and amount. Okay, number of ways to make amount using coins. Okay, so we have to choice, take coin, reduce amount, stay on the same coin. Okay, skip coin, move to the next coin, skip, solve of v2 I plus 1, and so the answer is take plus skip. So this is a recursion idea, but recursion is slow, so we going to use dp in 1d dp. Okay, in 1d dp. See, so the idea is dp of amount, ways to make amount, and group coins first, then numbers. Recurrence of this is dp of current amount plus equal to dp of current amount minus coins. Okay, this is a recurrence. Now let's try run. See, initializing with dp array, dp of 1 0 0 0 0, size is equal to amount plus 1. Okay, so the base case is dp of 0, it was 1, index 0, it was 1, so the amount 0 is one way. Okay, now let's try that. Let me see fast. So degree of current we can use 4 points. Okay, yes. See, okay. So the first coin is we take 1 2 only, 1 2, amount is 2. So the first coin is 1. Loop amount, current amount is equal to coin to amount. So current amount is 1. So dp of 1 plus equal to dp of 1 minus 1. So it was dp of 0. So dp of 1 is equal to 0 plus 1. It was 1. So see, dp equal to, wait, so dp is equal to 1 1 0. Okay, next current amount is 2. Okay, yes, next current amount is 2. Current amount is 2. So dp of 2 is equal to dp of 2 minus 1. 2 minus 1 is equal to dp of 1. So dp of 2, 0 plus 1, it was 1. So wait, 0 1 1. Okay, see, using coin one way, okay, ways. So if amount 1 way, if amount 2 is 1 way, 1 plus 1. Okay, so second coin is 2. No place. Okay, if second coin is 2, so root amount current coin is 2. So current amount is 2. So dp of 2 plus equal to dp of 2 minus 2 equal to dp of 0. So dp of 2, 1 plus 1 is equal to 2. Okay, so now dp table is 1 1 2. See, using coin 2 ways, so amount is 2, add 2, so there are total 2 ways. Okay, so yes, so the final answer is dp of 2 2. So there are total 2 ways. Okay, now write down. See, we make 1 dp array. We set 0 base case. We loop coin first, and for each coin group amount from coin to amount. We update dp current amount, so we return dp amount. Now let's try it, convert the code in dp. Vector of t-wall vector int dp amount plus 1, initializing with full or 0, base case dp of 0 is equal to 1. Next, for int zero and coin is 2 coins. Okay, yeah, for int current amount equal to coin coin. Current amount is greater or greater than to amount. Now current amount this place. Okay, next dp of dp of current amount equal to dp of current amount minus coin. Okay, this is our equivalence, and in the end we just return dp of amount. Submit this. Overflow of current amount think overflow because of enter I have to write wrong long for in long what happened value type dp current amount type value data translation which data type I have to use. What was the recurrence? Current amount minus research. I think I have to use the data type enter with initial is 0 and current yes. Okay, I have to use because the dp of 0 base case is 1. This is exactly one way to make 0 cents by using no coins. The nested proof by iterating through each coin first and then updating the amount. So you ensure that you are counting combination where the order does not matter rather than permutation as in. Yes, that. uh, so because of integer overflow, even so we use long wrong dp because it 64 bits I think. Construction, yeah. Yes, that's it. So that's it. Because of from see recursion, direct recursion, dp and 1d dp array dp of dp of amount. Base case amount is 0, so that was one way. Loop coins amount update dp. Now we try them track dp array, understand how way to add up. Okay, in last we have just written dp of array. That's it.